Hi everyone, welcome back to The Learning Curve. Today we're diving into calorimetry, one of the most important skills you need for energetics in both IB and A-level chemistry. Let's start simple. Calorimetry is just a fancy way of saying measuring heat changes in a chemical reaction. Think of it as chemistry's version of a smart thermometer, not only measuring temperature changes but telling us how much energy is moving around. And the big question we're always asking is, how much energy is transferred in a reaction? That's where the formula comes in. The magic equation is Q equals mc delta T, where Q is the heat energy change in joules, m is the mass of the substance that changes temperature, usually water or a solution, c is the specific heat capacity, a measurement of how much energy it takes to heat 1 gram of a substance by 1 degree Celsius, and delta T is the temperature change in degrees Celsius or Kelvin. And good news, you don't need to memorize the specific heat capacity for exams. If it's water, it's usually 4.18 joule per gram per degree, and it will be given to you when needed. Quick note, if you're a bit rusty on what exothermic and endothermic reactions mean, I've made a full video on that topic. Go check it out first and then come back here. It will make this lesson way easier. Here's the logic. When a reaction happens in solution, it either releases or absorbs heat. That heat is transferred to the water or solution, which then changes temperature. By measuring the temperature change, we can calculate the energy change. So, calorimetry is basically chemistry's detective tool for energy. Now, calculating Q is often only the first step. In exams, you'll often be asked to calculate the molar enthalpy change, delta H. That's just taking Q and dividing by the number of moles of substance that reacted. The formula is delta H equals negative Q divided by N. The negative sign reminds us, if heat energy is released, the reaction is exothermic, which means delta H is negative. If energy is absorbed, the reaction is endothermic, which means delta H is positive. Let's say we're neutralizing hydrochloric acid with sodium hydroxide. You mix 25 cubic centimeters of 1 molar hydrochloric acid solution with 25 cubic centimeters of 1 molar sodium hydroxide solution. And the temperature rises by 6.5 degrees Celsius. Assume the solution has the same density and specific heat capacity as water. As a first step, we're going to calculate the mass of the solution. We have 2 times 25 grams, so a total of 50 grams. Next, we're calculating the heat change. Q is mc delta T, so 50 times 4.18 times 6.5, so about 1358 joules. Note how the positive temperature change leads to a positive energy change. Next, we check how many moles reacted. We have 25 cubic centimeters of 1 molar solution. That translates to 0.025 mole. Now, as a final step, we calculate delta H. We substitute our values and we get negative 54,320 joules per mole. Pro tip, always divide by the moles of the limiting reagent. In our case, both are equal, so just take 0.025 mole. Alright, let's test your skills with a past paper style problem. When 1.5 gram of zinc reacts with excess copper 2 sulfate solution, the temperature of 100 gram of solution rises by 6.5 degrees Celsius. Calculate the enthalpy change of the reaction per mole of zinc and state whether this is exothermic or endothermic. Pause the video and give it a try. Here's the solution. First, we calculate Q. Next, we calculate the moles of zinc. And lastly, we plug both these values into our formula. So the enthalpy change is negative 119 kilojoule per mole, which means the reaction is exothermic. And that's calorimetry in a nutshell. If you found this helpful, hit like, subscribe to The Learning Curve and check the playlist for more IGCSE, A-level and IB chemistry videos. And don't forget, if you need to refresh exothermic versus endothermic basics, the video is linked in the description below. See you next time!